Okay, the next thing that we want to do after finishing our motion correction is slice timing. And to do slice timing, we use the button here on the menu top left, and this is the button in the middle, slice timing. Once you click on that, the batch window should appear, and you'll see these options. Again, you'll see a bunch of X's, which means that there's a bunch of things that you need to fill in. What do we need to fill in here? Well, as usual, just like in the motion correction, you'll have to tell SPM where the data are that you want to apply the slice timing on. So here in the data field, you can, if you highlight it, SPM will allow you to specify a new session. And just like in motion correction, we had 2 sessions or 2 runs. So it's the same thing here. We want to click one session one time. Let's click it one more time because we have 2 sessions. And then we have to go ahead and specify which data we want to apply the slice timing on for the first session. And that's going to be the motion corrected resliced EPI images, right? With the R prefix in front, if you recall from the tutorial on realignment. After realignment and doing reslicing, the EPI images would have a R prefixed in front of their file names. So that's the series of data that we want to select in here. So let's go ahead and do that. I'm going to click specify, and then the window will appear for you to select your data, and I'm just going to go to Y01. And remember, what we want are the files with the R prefix. So there's a bunch of files here, and here's a neat trick to make things simple. You can actually use the filter, and you say, I only want, you tell SPM that I only want files with the R in front. So you just type in R here in front of the dot and asterisk. That's the, those are the wildcards in Linux language, okay? You just type in R, then you hit enter, and you'll see that only what will remain are the files that have a R in front. And then you might see some other files, but the key thing is that that's because of the way the wildcards work, okay? But the key thing is that you have the rep1 and rep2 filtered out so you don't get confused with the R in front. And these are the series 23 and 25 that we operated on before. In addition, we want to have only for series 23. So we can do R wildcard 23, and we hit enter. Oh, sorry. That doesn't make any difference because all 3 have a 23 there, as you can see. So actually, to make it even more salient, you're just going to put a dash in front because the underscore will highlight this one. So if you hit enter here, there should be only one series highlighted now because there's only one file that has the R in front and also the underscore 23 in its file name. All right, so that's how you use the filtering. In addition, we note that this is going to be the same. We need to specify 150 frames, all right, because this is an EPI with 150 time points. So I'm going to go ahead and do 1:150 and hit enter. And it's going to be really simple. I'm just going to drag down and just hold on to Shift, then click the last file, and it will select all 150 files in there. And I'm going to click done. All right, I'm going to go ahead and specify the next session. And I'm going to do it quick because by now you should be very familiar with how to use this interface. I'm going to filter for R prefix series 25, if you understand what I'm doing here. And I'm going to specify that there are 150 frames that I want to select. Go all the way down. Do a quick check, select that. Okay, so I have now selected my motion corrected resliced run 1 image and run 2 image. Next, I want to specify the number of slices, the TR and TA and slice order, information that SPM needs in order to do the slice timing interpolation, which we explained in class, right? All right, so how do we know how many slices there are in the images? Well, remember we had the ability to look at some details in the header information by using SPM display, right? So let's go and do that if you forgot. At any time, this is also to show you, if at any time you need to kind of review this information, it's okay to kind of like pause, figure things out first, and kind of think of where you can get such information, and then get it, and then fill in the details. So we know that previously when we use display, it's gonna have this window out. We could see how many slices there are, right? And actually, you can kind of tell in the file name that there are actually 32 slices in the EPIs. But just to confirm, I'm just going to click that, and I'm going to validate that that's true. Yeah, so you see the dimensions are 64, 64, 32. So 32 is in the Z direction, and 32 is the number of slices in the data, in the EPI data that we're working with. So if we click number of slices here, and we click specify, just click type 32, click OK, and there you go. And then the TR, this is something that we can't really see from the header. You're just going to have to take my word for it that the TR for this study data that we are working with is 2 seconds. All right. So note at the bottom says TR, enter the TR in seconds. TR is the repetition time, which is the time it takes for the scanner to complete all 32 slices for this EPI scan. All right. This information actually is in header, but because it's not being displayed in this SPM display here, it's actually available if you use MRI cron, and I'll show that to you in another tutorial, maybe sometime else. All right, but for now, just know that the TR is 2 seconds for this study. The next field that it requires you to specify is the TA. And that's more of the interslice time, all right? And to do that, it actually tells you enter the TA in seconds, which is usually calculated as TR minus TR over number of slices. So this is a complicated number, but you can actually use MATLAB directly here to get what that number is. So here's a trick. You click specify, just follow the formula. The TR is 2 minus, open parentheses, 2, TR again, over the number of slices, which is 32. Just, directly type in these numbers as you know what the TR and number of slices are. And when you hit OK, it will calculate the actual value of that result, which is 1.9375. Really easy. Okay, next is the slice order, and we will talk about this in class, what the slice order means and why do we have to specify it. But you should know that, and we should have talked about it in class before, that the slice order in this case for this study is going to be 2, skip 2 to 32, followed by 1, skip 2 to 32. If you enter this, what this will result in, if you hit OK here, this is specifying 2 vectors, okay? That in the first vector, I want the numbers 2, 4, 6, 8, all the way to 32, okay? That's what this 2 skip 2 to 32 means. And in the next vector, which continues from the first vector, okay, so we kind of concatenate them together, will be the numbers 1, 3, 5, 7, all the way to 32. Or rather 31, all right? But MATLAB will take care of that when you specify this, and you'll see that if you click OK, the result would be a 32 dimensional vector, okay? So you can see 2468, etc., all the way to 32, followed by 1357, etc., all the way to 31. So this is the slice order, which tells SPM which slice was acquired in what order. And in this case, we want the reference slice to be the first slice, which is actually slice number 2. Okay, so that's going to be the next field here. And if you read carefully, enter the reference slice. If slice times are provided, etc., then this would be the reference time instead. What this is basically to tell SPM the slice that you want to kind of apply the slice timing adjustment to move all the slices to in that point in time. And we will talk about this in class, but you should know that in this case, in our case, because the acquisition order is starting from 246 and then 135, yeah, in the slice order, then the first slice that was acquired was actually slice number 2. And we do want to bring all of our slices to the first point in time, which is the time of slice number 2. That's what we'll enter here. And do note that there will be a prefix, which is an A, that will be placed in front of these files. So if we go back here, you'll note that these files already have an R in front. So what it will do is it will add an A in front of these, so you will end up with an AR file after the slice timing has been applied. As usual, we will save this batch, and I will name it just like the same name, like Y01, but I'll change it to slice timing. Save it, save this job, right? And the green button is on, so go ahead and run it. Once it's run, just let it run quickly. You will see that it will generate the AR files for series 23 and then subsequently for series 25 as well. And then you're done. Slice timing is done.